a favorite movie of mine. You know what happened in this movie. And so imagine the sequel to this movie, except the ship is much, much bigger. And perhaps 30 years ago, some people thought maybe off in the distance there was an iceberg. Most of the people said, no, you're seeing things. But over in the last decade, more and more people have begun to say, yes, there's an iceberg. It looks like we're heading for it. Some people don't want to see it still or want to look the other way. That's okay, but most of the people can see there's an iceberg. And then all of a sudden, the engineers on board are saying, we have some bad news. Two things. One is, it's not a question of whether we're going to hit the iceberg or not. It's whether we're going to hit it a glancing blow, and we'll see, let's say, a 2 or 3 degree increase in the climate, or we hit it dead on, we can see a 5 or 6 degree increase. And oh, by the way, it will take about 50 years to turn the ship. And oh, by the way, we don't really know how to turn it today. Okay? Now, the sequel hasn't been written yet, so let me offer some hope as to the fact that we can turn the ship. But you have to realize it will not turn in a decade. So as an offer of hope, let me remind you of something Paul Ehrlich said in a bestseller, The Population Bomb. He said the battle to feed all of humanity is over. In the 1970s and 1980s, hundreds of millions of people will starve to death in spite of any crash programs embarked upon now. So what happened? The book went to press in 1968. In 1970, Norman Borlaug got the Nobel Prize for Peace for the Green Revolution. What did he do? He developed strains of wheat, dwarf wheat, that when planted in countries like India, Pakistan, and Mexico, increased the productivity of wheat per acre 4-fold and 5-fold. And as a result of that, we went from a world of 3 billion people in 1960 to over 6 billion people in 2000, close to 6.3 today. This is the amount of land put under production for cereals. This is the productivity of grains worldwide. Okay, that kind of saved the massive starvation of hundreds of millions of people because of the very high yields of these crops. Another miracle happened at the turn of the 19th to 20th century. Fritz Haber invented a process where you can synthesize ammonia. Once you synthesize ammonia, you can make nitrogen-based fertilizer. And this was considered a big deal because Europe at the time, as we went into the 20th century, had a severe depleted soils problem, and they were facing starvation. And the technological fixes being considered were either you use the developing world, the new world, to raise the food to ship it to Europe, or you actually take their soil and ship the soil to Europe. But once you had, and you know, economists would discuss which one to do, but a chemist invented a way to produce artificial nitrogen-based fertilizer, considered so important, got the Nobel Prize for it. Then another chemist, Karl Bosch, figured out a way to make it economically viable, considered so important, got a second Nobel Prize. There was a third Nobel Prize given in 2007 to a surface chemist that began to get a glimmer as to how this stuff actually worked at a microscopic scale. So 2.5 Nobel Prizes, and it's actually justified because it was a big deal. So let me talk about what we can do about it. It's often said the wealth of a country is proportional to the energy it uses and its carbon footprint. And yesterday afternoon, we saw electricity consumption versus human development index, which is, as pointed out by the speaker yesterday, probably a better measure of the wealth of a country because it includes the GDP, the level of education, and health care. And so what you see, for example, Norway, Canada, I think Sweden is somewhere around here, very high users of electricity, very high standard of living. You see Pakistan, India, China, Zimbabwe down here, and it is absolutely true. If you're down here, you will need to use more energy to get your standard of living up here. However, I see a different sort of graph. I see yes, you need to increase your energy down here, but once you reach a certain standard of living, it's flat. Okay? Between Japan, France, Netherlands, now these are very big hydroelectric, so electricity is very inexpensive in Norway, Canada, and Sweden. US less so. But by the time you're up here, your standard of living has not increased, even though your energy use has increased. These countries want to get down to here. These countries, this one especially, also needs to get down to here. It's essential that these countries need to get down here and maintain their standard of living to create headroom for the other countries to come up. And I think it's possible. Is it possible in the United States? Well, this is electricity use in the United States. This was the first oil crisis. In the first oil crisis, California took note of this. It was almost the same as the rest of the United States. And they set a bunch of policies, statewide policies. Both the Republicans and the Democrats supported it, which meant that the average use per person of electricity in California remained flat for the next 30 years, even though the GDP doubled. So that's another existence proof that levelizing the use of energy does not mean a collapse of the economy. It is possible to do this. So here's another frequently quoted saying that energy efficiency and CO2 reductions are not affordable. So here's a graph of refrigerator efficiency. This is the energy use of a refrigerator in blue, climbing, climbing, climbing. And again, in the first oil crisis, what California did was it started to institute standards of refrigerator efficiency beginning around this time. They gave industry a few-year lead time, and lo and behold, the efficiency increased. And so the energy used per refrigerator went down by a factor of 4, even though the average size of the refrigerator went from 18 cubic feet to 22 cubic feet. You notice it's still rising because the American appetite is not yet sated. It's flattening out. Why? Because of the size of the kitchen door. So they're making them wider. The industry felt that if you wanted to make energy efficient refrigerators, the homeowner could simply not afford it. This turned out not to be true. This is the inflation adjusted price of refrigerators. It went down by a factor of 2. Because with better insulation, you could make a smaller compressor. There's a better duty cycle for the compressor. The compressor was the most expensive part of the refrigerator. So once